Continuous integration, or CI, is one important part of the software development process, where a shared code repository is continuously changing due to new work of a team member being integrated into it. To ensure the high quality of the code and reduce potential errors, each integration is usually verified by an automated build and test process. In this video, we will learn how to set up that process using Github Actions to automatically build and run unit tests for our simple bank project, which is written in Golang and using Postgres as its main database. Github Actions is a service offered by GitHub that has similar functionality as other CI tools like Jenkins, Travis, or CircleCI. In order to use Github Actions, we should define a workflow. Workflow is basically an automated procedure that's made up of one or more jobs. It can be triggered by three different ways: by an event that happens on the GitHub repository, by setting a repetitive schedule, or manually clicking on the Run Workflow button on the repository UI. To create a workflow, we just need to add a YAML file to the GitHub Workflows folder in our repository. For example, this is a workflow file ci.yaml. The name of this workflow is build and test. We can define how it will be triggered using the on keyword. This is an event that will trigger the workflow whenever a change is pushed to the master branch. And this is a scheduled trigger that will run the workflow every 15 minutes. Then we define the list of jobs to run in this section of the workflow YAML file. In order to run the jobs, we must specify a runner for each of them. A runner is simply a server that listens for available jobs, and it will run only one job at a time. We can use GitHub hosted runner directly or specify our own self-hosted runner. The runners will run the jobs, then report their progress, logs, and results back to GitHub, so we can easily check it on the UI of the repository. We use a run-on keyword to specify the runner we want to use. In this example workflow, we're using GitHub's hosted runner for Ubuntu's latest version. Now let's talk about job. A job is a set of steps that will be executed on the same runner. Normally, all jobs in the workflow run in parallel, except when you have some jobs that depend on each other. Then they will be run serially, one after another. The jobs are listed inside the workflow under the jobs keyword. In this example, we have two jobs. The first one is build, which has two steps: check out the code and build the server. The second job is test, which will run the test of the application. Here we use a needs keyword to say that this test job depends on the build job, so that it can only be run after our application is successfully built. This test job only has one step that runs a test server script. Steps are individual tasks that run serially, one after another within a job. A step can contain one or multiple actions. Action is basically a standalone command, like the one that runs the test server script that we've seen before. If a step contains multiple actions, they will be run serially. And an interesting thing about action is that it can be reused. So if someone has already written a GitHub action that we need, we can actually use it in our workflow. Let's take a look at this example. Here we use a steps keyword to list out all steps that we want to run in our job. The first step is to check out the code from GitHub to our runner machine. To do that, we just use a GitHub Actions checkout version 2, which has already been written by the GitHub Action team. The second step is to build our application server. In this case, we provide our own action, which is simply running the build server script that we've created in the repository. And that's it. Now before jumping into coding, let's do a quick summary. We can trigger a workflow by three ways: event, scheduled, or manually. A workflow consists of one or multiple jobs. A job is composed of multiple steps, and each step can have one or more actions. All jobs inside a workflow normally run in parallel, unless they depend on each other. Then in that case, they run serially. Each job will be run separately by a specific runner. The runners will report progress, logs, and results of the jobs back to GitHub, and we can check them directly on GitHub repositories UI. Alright, now let's learn how to set up a real workflow for our Golang application so that it can connect to Postgres and run all the unit tests that we've written in previous lectures whenever new changes are pushed to GitHub. Okay, this is our simple bank repository on GitHub. Let's select the Actions tab. GitHub knows that our project is written mainly in Go, so it suggests us to set up the workflow for Go. Let's click this Setup button. As you can see, a new file go.yaml is being created under the folder .github/workflows of our repository. We can edit this file directly here using this GitHub editor. However, I prefer to add the file to our local repository first, then edit it locally with Visual Studio Code before pushing to GitHub. So let's open our Simplebank project folder in the terminal. I'm going to create a new folder .github/workflows. Then create a new YAML file for a workflow inside this folder. You can name it whatever you want. Just make sure it has YAML extension. For me, I'm just going to use ci.yaml to be simple. Now let's open this project in Visual Studio Code. Here we can see the ci.yaml file under the GitHub Workflows folder. Let's go back to GitHub and copy this file content, then paste it to our ci.yaml file. First, we need to set a name for this workflow. For example, CI test. This name will be displayed in our GitHub repository's action page. Then we define the event that can trigger this workflow. Normally, we would want to run tests whenever there's a change being pushed to the master branch, or when there's a pull request to merge into the master branch. There are many other events that you can use. Please refer to the GitHub Action documentation to know more about them. Next, we're going to set up the jobs. In this template that GitHub provides us, we have only one job. Its name is build, and it runs on a Ubuntu runner. There are several steps in this job. The first step is to set up or install Go into the runner. In this step, we just need to use the existing GitHub action called setup Go version 2, and we use the with keyword to provide input parameters to this action. In this case, we could ask it to use a specific version of Go, such as version 1.15. This ID field is just a unique identifier of this step. We might need it if we want to refer to this step in other contexts. The second step is to check out the code of this repository into the runner. To do that, we also reuse an existing action, checkout version 2. The next step is to get all the dependencies or external packages that our project is using. In fact, we don't need this step because Go mode will automatically download missing libraries when we build the application or run the test. This build step is also not necessary because the application will be built automatically when we run Go test. So the last step is to run our unit test. We already have a make test command defined in the makefile for this purpose. Therefore, all we have to do in this step is to call make test. Alright, now I think we should rename this job to test because that's the main purpose of it. So we're done with the first basic version of our CI workflow. It might not work yet because we haven't set up the Postgres database. But let's just push it to GitHub to see how it runs. First, we run git status to check the status of our local repository. Here we can see the newly added GitHub folder. Let's run git add dot to add all new changes to the list of our commit. Then run git commit with a message saying init CI workflow. Okay, now we run git push origin master to push this change to GitHub. Then go back to our repository page and select Actions tab. Now we can see our CI test workflow here, and there's a new run of it for our commit. When we open this run, we can see one job in progress, test. Now all steps are listed on the right. The setup job, setup Go, and checkout code steps are finished successfully, and the test step is still running. We can click on this icon to see the logs. Now the test step has finished, but it failed. We know that because of the red X icon next to it. This is expected, because as we are seeing in the logs, the code cannot connect to port 5432 of Postgres, since we haven't set it up in our workflow yet. So let's do that now. Let's search for GitHub Action Postgres. and open this official GitHub Action documentation page. Scroll down a bit. Here in this section, we can see that Postgres is declared as an external service of this job. Let's copy this block of code and paste it to our workflow file. So we use the services keyword to specify a list of external services that we want to run together with our job. In this case, we only need one service, which is Postgres. And since we are using Postgres version 12 in our project, let's set this Docker image name to Postgres 12. You can check out available versions and tags of this Postgres image on Docker Hub. Next, we need to set up some environment variables for the credential to access the database. If you still remember, we're using this secret password in our local Postgres container. So let's set the same value here for our CI workflow. We're also using root user to connect to Postgres. So let's set this environment variable here as well. One last thing we need to set is the database name, which is SimpleBank. In the documentation of the Postgres image, it says we can set the default database name with this PostgresDB environment variable. So let's copy it and set it to SimpleBank in our workflow. Now this health check option is used to tell the runner how to check if Postgres has started successfully or not, so that it can know when to run the next steps in the workflow. That's great, because we only want our test to be run after Postgres is started. Otherwise, the test will still fail, because it cannot connect to the database, right? Okay, now Postgres service is defined. But in order for our test to run successfully, we also need to run DB migrations to create the correct database schema for our application. So let's define a new step here. After the checkout code step, its name will be run migrations. And the only action it needs to do is to run make migrate up. Alright, now let's try to push these new workflow changes to GitHub to see what will happen. Okay, now in our repository's actions page, we can see a new run for our new commit. Let's open it. Here the test job is still running. The job is set up successfully, and now it's initializing the containers. From the logs, we know that it's still waiting for Postgres service to be ready. As soon as Postgres is up, all following steps are run immediately. Here we can see a log saying Postgres service is healthy. The setup go step is also successful. Then it check out the new code. Now the migration step is failing. Let's find out why. Okay, it failed because migrate is not found. We forgot to install the Golang Migrate CLI tool to run the migration. So let's search for it. Open its GitHub page. Click on this CLI link and follow its documentation. There are several options depending on the OS that you use. We're using Ubuntu for our runner, so I'm going to copy this curl command to download a pre-built binary of the migrate CLI. Now in the workflow, let's add a new step to install Golang migrate. Then in the run action, let's paste in the curl command. We have to set the correct URL for the version of migrate CLI and the platform we want to use. So let's click on this release downloads link. The latest release is version 4.12.2, and because our Ubuntu runner is a Linux platform, let's copy this Linux AMD64 link address. Then paste it to our curl command. It will download the zip file and unzip it to give us the migrate binary. Now in order for the migrate command to work, we have to move that binary to the user/bin folder. So this step will include more than just one curl command. We use this vertical pipe character here to specify a multi-line command. Now let's try to run this curl command in our local machine to see the file name it gives us. It's migrate.linux AMD64. We have to move it to the user/bin folder in the runner machine. So let's go back to our code and add this move command. Now note that only a super user can change the content of the user/bin folder. So we have to run this command with sudo. Let's add one more command here, which migrate, just to check if the migrate CLI binary is successfully installed and ready to be used in the runner or not. Okay, let's remove the binary in our local machine. Commit the new change of our workflow and push it to GitHub. Now let's check our repository's action page. A new run is started. Let's wait a bit for it to finish. Now the job is still failing, but this time it fails at the install Golang migrate step. From the logs, we can say that the binary file was successfully downloaded. So it might fail because of the move command or the which migrate command. Okay, I know why. That's because we're just moving the file migrate.linuxamd64 to user/bin, but we don't rename it to migrate. So when we run which migrate, it cannot find any binary with that name. All we have to do now is to add migrate to the end of the move command, so that the binary file is moved to user/bin with a new name, migrate. This will ensure that when the make migrate up command is run, the correct migrate CLI binary will be used. Alright, let's add this new change. Commit it and push it to GitHub. Then go back to our repository's action page to check the job status. It's still running. Let's wait a bit. Okay, it's finished now, but still failing. However, this time the install Golang migrate step is successful. The step that fails is run migrations. And the reason is, it still cannot connect to port 5432 of our Postgres container. Why? We've already added Postgres to the services list, right? Well, yes, but we haven't exposed its local port to the external host yet. That's why our code still cannot connect to the port. So let's go back to the GitHub Action documentation page and scroll down a little more to see how to configure port mapping. Here it is. We can use this port keyword to specify the ports that we want to expose to the external host, just like what we normally do in our Docker Compose file. Okay, now let's add it to our CI workflow. The default port 5432 of Postgres is now available to our job runner to access. Let's add this new change, commit it, and push the change to GitHub. Hopefully this time it will work. Okay, let's open the action page. The job is still running. Let's be patient and wait for it a bit. It's done. All green ticks. So finally our CI test workflow runs successfully. You can see all the logs of each step. Here's the logs of our unit test. After all steps in our workflow are completed, GitHub does some cleanup steps and stop the containers. And that's it. We have learned about continuous integration by writing our first GitHub Action workflow to run Golang unit tests that needs to connect to an external Postgres service. There are a lot more things that GitHub Action can do. I encourage you to check out its official documentation to learn more about them. I will put the link in the descriptions. And that brings us to the end of this video. Thanks a lot for watching. I'll see you guys in the next lecture.